All right, so we are going to do a review now for Unit 3 test coming up later next week. I will be doing a Zoom session as well on Tuesday during the normal time of class. This will be better, but the Zoom session will be good too. So you can do both, you can do that, you can do this, whatever. They're all going to be about the same. So I posted a study guide, and this is it. You're going to have a test. We'll have 8 chemical equations given. In other words, you'll have the ones you've been practicing with blanks. Then you'll have 5 in sentence form, which means there's words, and you have to turn those words into letters. You'll have to crisscross too, so don't forget to do that. And look at the polyatomic chart, but the words will all be there. Then you'll have one really hard one, which will not have the answer. In other words, it'll say, for example, methane burns in the presence of oxygen, yielding, and you have to know what it yields and write it down and balance it and crisscross it. All right, so you have one like that, but I'll give you that one. Okay, here's the definitions you have to know. You got to know your electrolytes, and again, strength of those just has to do with how much they dissociate. None, a little, or fully. All right. You'll have to know some different kinds of reactions, precipitation reactions. You'll have to know that that means that you get a solid that comes out. That's where the S comes from. You have to know combustion reactions. And again, the hint for that I said is, do you have anything with burning, heating, oxygen? That's the key, that it's a combustion reaction. Again, this is a matching. You have to know these for matching. Spectator ions, those are the ones that they don't participate. Again, these definitions are all in the slides. You're just going to want to study those. I'm just kind of pointing out a few of them. Decomposition reactions are ones where they break down. Molecular equations, those are just equations where you actually see how many letters there are for each element. And then you have your acids and bases. What is meant by that is the definition. All right, not solving a problem with them, just the definition. So again, look up all these, they're in the slides. Charts and tables provided, typically that means they would be stapled to your test if this was an on-campus class. Those are just things you can bring with you. Your solubility chart in the slides for this unit, and then the periodic table and the polyatomic chart. Those are in the slides from the last unit. This is an example of where we build. And in the next unit, Unit 4, you got to have all this and then some new stuff. So it just keeps building as we go. Okay, so now I'm going to grab the test, and I'm going to go over the test with you. All right, this is supplemental. Let's talk about the equations that you have to know how to do. I'm just going to read them to you, and you can write these down and you can practice them. And we might go over them on Zoom next week if you haven't figured them out. Some of these you've probably already seen. Okay, the first set of equations are ones where I give you everything. All you have to do is fill in the blank, and the blank is just the coefficient. So it's N2G, that just means gas, plus H2O gas, and there's a blank in front of each. All right. So those will be set up as fill in the blanks. You just have to put the number in the blank. It should grade it automatically, but I'll always double check it. Arrow, a blank, NO, G in parentheses, plus a blank, and H2G in parentheses. So basically it's nitrogen plus water yields nitric oxide plus hydrogen gas. You have to balance it though. All right. So let's do this one together. You look at it and you say, well, let's see, there's 2 nitrogens on the left. Let me put 2 on the right. So you put a 2 over there. Problem is that now gives you 2 oxygens. So you come back to the left, and you can fix that. You just put a 2 in front of the H2O, but the problem with doing that is it gives you 4 hydrogens. How do you solve that on the right? You just put a 2 in front of the H2, and that gives you 4 hydrogens, all right? So the answer would be, if you were filling in the blanks, it would be a 1, 2, 2, 2. Do not leave a blank empty when you want to put a 1. You could do that on paper and get 100, but the test won't let you. Again, I'm going to go back and edit it, so don't worry about it, but you want to properly do the test. Blanks that deserve nothing, in other words, a 1, you got to put a 1 there, or the test won't grade it properly, all right? Okay, here's another one. Magnesium, I'm going to stop saying the S's and G's for now because they don't matter, plus oxygen yields magnesium oxide, right? So it's Mg plus O2 arrow MgO. Crisscrossing is all done. You don't have to worry about that. In fact, don't do that in these problems. That's been done. If you do that, you're altering the substance. Just put the coefficient. So there's a magnesium on the left, there's 2 oxygens. So I got to put a 2 on the right in front of the whole thing. The problem is it gives me 2 magnesiums. I just come back to the left to fix that by putting a 2 in front of the magnesium, and now it all balances. So it's 2, 1, 2. All right. All right. Another one you have to do is BaF2 plus hydrosulfuric acid, which is just H2SO4. Arrow, this is a double displacement reaction, so they switch partners. BaSO4 plus HF, balance that one. All right, that one's pretty easy. You guys can figure that one out. All right, another one you have to know is sodium iodine. That's NaI, sodium iodine, plus Cl2, arrow, sodium chloride, plus I2. All right, you gotta know how to balance that one, so practice that one. Another one is MgCl2, magnesium chloride, plus HBr, arrow, a double replacement, so they both switch partners, MgBr2, HCl. All right, so you got to put a number in front of each of those. It might be a 1, but you got to put something there. You got another one that's PBr3 plus H2O gives you H3PO4 plus HBr, another double replacement. Again, the best way to do these is to Google them and watch somebody on YouTube solving them. They draw the line down the middle, they account for everything on the left, everything on the right, and then they sit there and look at it and say, oh, you got too much oxygen. I got to add more to the left. So you cross that off and you change it to the new number. Then, of course, you go back up to the equation and you make that change. That's the best way to do it. Watch somebody do it, because some of these are tricky. You get into tricky numbers. I'm going to give you pretty easy ones, but you'll see some tricks when you're solving them. Okay, another one is iron, then parentheses, NO3, close parentheses, 2. Okay, that's iron nitrate, but you remember, because it's polyatomic, and you've crisscrossed the iron 2, you got to put the 2 outside the parentheses, right? But what that means is that everything in the parentheses is multiplied by 2. So there's 2 nitrogens and 6 oxygens. Don't forget that. All right, so it's Fe parentheses NO3 close parentheses 2 plus H2S yields FeS plus HNO3. All right, that's it for the 8 chemical equations given, whatever. That's what you're going to get. I might have omitted a few. I took out a few hard ones, so there might not be 8 there. All right, let's do word problems now. Here's an example of a word problem. Solid glucose, and I actually give you the equation. All right, you don't need to know this, but it's going to be given to you. It's C6H12O6. That's glucose. All right, but when you're practicing this, if you're not sure what it is, just Google it. That's the way to learn it the first time through. You can't do that in the test, but you can just do it as you're learning it. So solid glucose is burned in air. Oh, that's your clue. That's a combustion reaction. Now you might be like, so what do I care? I don't have to categorize it. You may have to know what to put at the other side of the arrow. That's why you have to know that. It's burned in air to produce carbon dioxide and water vapor. Now here's an easy one. I'm giving you everything. I'm giving you A plus the B, arrow, the C, and the D. I'm giving you everything. All you got to do is turn the words into letters. All right, so burning in the presence of air doesn't really clue you into the answer because the answer is given. You just have to turn it into letters and numbers. All right, so glucose, I gave you the equation for that. So you just write that down, C6H12O6. Don't forget, now is important to get the letters. Parentheses, little s. Do not forget that, because if you forget that 4 times on 8 problems, that's a lot of points you're going to miss. So don't forget it. How do you know it's a solid? I tell you, it says solid glucose. That's an easy one. Plus air. What's air? That's tricky, because you might be like, I don't know. Or you'll be like, oh, that's oxygen. Put an O. Nope, both are wrong. It's O2. You have to know that, have no fear of ice cold beer. You have to know your diatomics. And again, they're pretty easy, right? They're hydrogen, nitrogen, and oxygen, and then everything down that column on the right side. All right? But you got to know that. You have to know that when I say air, not only do I mean O, I mean O2. You won't be able to balance it if you don't do that. So it's O2, and then you spent so much time figuring that out, I bet you forgot to do parentheses G for gas. All right, how'd you know that it was gas? Well, I mean, come on, right? Let's do some common sense. It's air. It's a gas. All right, arrow. And carbon dioxide, what's that? Again, you know that one. But if you ever got tricked in the word, it's type 3, it tells you it's carbon, C, dioxide, O2. So it's CO2. One, you already know that. Two, the word tells you because it's an organic compound. And water vapor. Oh, by the way, let me go back. So it's carbon dioxide. What's the letter? G. How did I know that? Again, come on. It's carbon dioxide. It's a gas. This one is a little tricky too, but it's still common sense. Plus water vapor. What is water vapor? It's H2O parentheses gas parentheses G. That's what water vapor is. That's a little tricky because you might not have thought that like steam coming off your spaghetti is a gas, but it is. It's water vapor, so it's a gas. All right, so that's now you're not done yet. You now have to balance it. You got all your crisscrosses are done. They were kind of done for you, but they're all done. But now you got to balance it. So now you got to actually go through and say, I've got 6 carbons on the left. How many do I have on the right? 1. I got to put a 6 there, but that gives me 6 oxygens plus 2 plus the other one, etc. Okay, so Google that one. Watch somebody solve it. You'll have that one on there. All right, let me give you another one. Nitrogen monoxide gas and diatomic hydrogen gas forming diatomic nitrogen gas and water vapor. All right, so let's go through this one. Nitrogen monoxide, that's a pretty easy one because I say the word nitrogen monoxide, so it's just NO. And I said gas, so you put the G, plus diatomic hydrogen gas. Diatomic means H2. You got to put the G for gas. If I've forgotten to say it, I'm going to say it now. When it says forming or yielding or making or producing, that's your clue in the word problem to put the arrow. Okay, so here it says gas forming diatomic. Arrow. Put an arrow. Diatomic nitrogen, that's obviously N for nitrogen. It's diatomic, that means it's a 2. Now don't be tricked. If I don't say diatomic hydrogen or diatomic nitrogen, you have to know to do that. You got to know have no fear of ice cold beer. Don't just stick a naked N on a page. You're going to get it wrong. And it won't balance, so you get that wrong too. So it's diatomic nitrogen gas, so it's N2 parentheses G plus water vapor. We just did that one, so it's H2OG. Now go back and balance it. Just remember, it's so much work to put these down that I know the temptation is going to be to fight really hard mentally to get the words turned into letters. You're not done. You still have to crisscross. We didn't have to do that yet, but you got to get those numbers down. And then when you're all done doing that, the temptation is to be like, oh, that was a lot of work. Next question. You haven't balanced it yet. You still have to balance it. All right. You might want to like make a little cheat sheet that says all the steps you have to do. Don't forget to crisscross. Sometimes you don't have to. These 2 examples you didn't because they were organic compounds. In the word was the balancing or was the numbering, like carbon dioxide. It tells you how many oxygens. And then make a little note. The very last thing you have to do in bold is balance it. Don't forget to balance it. Okay, let me just rip through these because we're running out of time. I just want to give them to you so you can practice them. All right? Calcium metal and water form calcium hydroxide and diatomic hydrogen gas. That's one where you're going to have to crisscross. All right, we might talk about that in Zoom next week. Solid magnesium nitride and water form ammonia gas and magnesium hydroxide. Ammonia gas is given to you as NH3, so that's given to you. Another one, it says lead-3 nitrate and sodium iodide forming sodium nitrate and lead-2 iodide. Okay, so crisscrossing is necessary in this one, and it's not done for you. Next one, and this is the last one, aluminum metal with solid diatomic fluorine forms solid aluminum fluoride. Okay. And then the bonus question is the one where you're given only the left and you got to figure out the right. And it is predict the type of reaction, products formed, and balance molecules and balance the equation for HCl plus KOH. All right, so that's the review. I will do a little bit more next week in Zoom, but it'll basically be the same thing. So if you have questions, that's the time to ask it. But for now, just go ahead and dive in, start solving these problems because you're going to see them again. All right.